Indiana University East, names and formulae of binary ionic compounds. Binary ionic compounds are ionic compounds that have only two elements in it, typically one metal and one non-metal. Okay, so sodium chloride, for example, here NaCl, you have one element, one metal and one non-metal. Na2O, sodium oxide, Na and O. Note that it doesn't mean you have two atoms listed, it means you have two different elements. AlCl3, a lot of these aluminum compounds, they are molecular, but they're named similarly to ionic compounds. The difficulty with naming these is that typically, or rather writing formulae for these, is that they typically form an infinite lattice. Okay, so we can't distinctly say in, say, a molecule of sodium chloride there is only one sodium and one chloride, because it's going to stretch essentially to infinity. So for these, because we don't know what the unit is, we just use the smallest combination of ions required to maintain a neutral charge and call that a formula unit. And for our calculations, we use that to solve problems. And it doesn't really matter, because as long as we know the correct ratio, we're going to be able to do our calculations. And so what we want to do is to find the number of atoms of each element per formula unit. And to do that, the crux of the issue is to balance the charges such that the formula unit has zero net charge. It is neutral. And we're going to start with the straightforward ones, specifically those ions where we have no ambiguity of charge. Okay, and in this case we write down the name of the cation, and then we write down the root, the base name of the anion, and we put "-ide". The "-ide" ending indicates that it is the non-metal atom only. And as a result, let's look at this. Let's look at this example. Sodium hydride. Sodium is Na plus. The hydride ion is H minus. So we have plus 1 and minus 1. 1 to 1. If I have 1 sodium and 1 hydride, plus 1 minus 1 gives me neutral charge. So I have a 1 to 1 ratio. And therefore, I can write down NaH, because that's the lowest combination that would work. If you look at zinc bromide, zinc is zinc 2 plus, and the bromide ion is Br minus. Here it gets a little bit more complicated. Here we have a plus 2 charge, and here we have a minus 1 charge. And so I need two of these to balance it out. So I need one zinc and two bromides, so that's zinc bromide. Let's look at aluminum oxide. This is a bit more complicated. So aluminum is Al 3 plus, and the oxide ion, so 2 minus, as you may know. So let's look at this. I have plus 3 here and minus 2. If I multiply this 2 by 2, I get a minus 4 charge, which is higher than the aluminum 3 plus. So I need 2 of these to give me plus 6, and then I can use 3 oxide ions to balance it out. So it is Al2O3. The reverse of this in terms of naming is relatively straightforward. Let's take an example. Here I have the cation is K, the anion is O. K is potassium and O is oxide. And so that's how you write down the name.